Hello and welcome. In this video, we'll take a look at how to use the XNPV function to compute the net present value of cash flows that happen at arbitrary dates. So for example, in this cash flow, you have the initial investment happening on 1st January, and then subsequently the first payment of $1,500 comes up on 30th June, and the next payment comes up on the 30th June of next year, and so on. So typically we would use the NPV function, but here we are going to use the XNPV function. So I'm just going to pull up that function here to give a brief overview. XNPV, and if I were to click on XNPV, if I were to search for XNPV, here is a function. So this function asks for three parameters. It asks for the interest rate, which is this 10% here. It asks for the values. Values is a series of cash flows that correspond to the schedule of payments. That is this series of cash flows. And the dates are these dates here. With respect to values, the one major difference between NPV and XNPV is that in XNPV, you would also specify the initial negative cash flow as well, whereas in NPV, you don't. So with that, let's go ahead and compute. So I'm just going to say NPV here. That's just to label this. So I use the XNPV calculation. The interest rate is 10%. Annual interest rate is 10%. The values are all of these values, including the initial negative cash flow. And the dates are all of these dates here. Then I close the parenthesis and press enter. And I can change this to the dollar sign so that it's $966 and $77. Just to see how you could compute this equivalently using first principles, what we'll do now is PV calc. So I just say PV calculations. So I'm going to compute the present value of each of these individual cash flows and add them up to obtain the net present value. The present value of the initial $5,000 outflow of cash is just 5,000. The present value of this 1,500 is this amount divided by 1 plus the annual interest rate raised to the power the difference between this and this date divided by 365. And I'm going to put this in parentheses. So this gives us a fraction of the year, right? So B6 minus B5 is the number of days that elapsed between this date and this date. That divided by 365 gives us how many years have elapsed. Now again, notice the connection between the interest rate we are using here and the year metric that we are using here. So that's what we compute here. So B6 minus B5 divided by 365 gives us a measure of the number of years that have elapsed since the original cash flow and this cash flow. Now I want to copy this formula down. Before doing that, I would like to make one small change. I would like to put a dollar sign before the 5 here, because as I copy this down, I want $5 to remain B5, whereas B6 should become B7, B8, and so on. I also want to put a dollar sign before the 2 here, and again the purpose is to make sure that I refer to this interest rate alone. In fact, I can without harm put a dollar sign before the D as well, because that interest rate at 10% is going to be fixed whether you copy it down or to the right. I press enter and I copy this now all the way down, and if you were to now sum all these cash flows, you should get the same value as this. And you can see that I'm just going to remove the dollar sign for a moment and increase the number of decimal places just to show you that this figure is exactly identical to this figure. In fact, if you were to go to the help for XNPV, and if you were to look at help on this function, you will see that the help outlines how XNPV is calculated. XNPV is the sum of these various cash flows, where the cash flow is divided by the interest rate. This is the annual interest rate raised to the power DI minus D1 by 365, where DI is the date of the corresponding payment D1 is the date of the 0th payment. And so you subtract one from the other, which gives you the number of days elapsed. And then you divide it by 365 to arrive at the number of years that have elapsed. And you raise the annual interest rate to that, the 1 plus the annual interest rate to that power. And that's exactly what we're doing in this formula here as well. So we're doing B8 minus B5, B9 minus B5, all divided by 365. And we are raising the 1 plus interest rate to that power. So that is a brief overview of how you would use the XNPV function. And you can see that it's pretty flexible in that supposing I were to change these dates here, I want to say 1st April 2015 and say 15 July 2017 and so on. So basically, if you have irregular cash flows and if you have irregular amounts, say 1700 and 1300 and so on, you can calculate all of those things using the XNPV function. One other thing to notice is that sometimes you might not have your XNPV function accessible to you immediately. If that is the case, then you should install it by going to File and Options, and within Options, click on Add-ins, and within Add-ins, scroll to the bottom and Manage Excel Add-ins. Click Go, and you will see what are the add-ins that are available and what are the add-ins that have been installed. Make sure to check the Analysis Tool Pack and click OK. The Analysis Tool Pack is the one that contains the XNPV function. So that's how you can make use of the XNPV function to calculate net present value for cash flows that happen at irregular time intervals. Excel will do the computations for you. I hope you found this useful. Thanks for watching.